This is going to be our last video in Chapter 4. It will cover homework assignment number 30 and it's on section 4.6. We're going to look at application problems. Now remember earlier we had a formula for figuring interest when we had our interest was compounded either, remember, quarterly, monthly, annually. Now suppose you have a continuous growth rate. Remember that word continuous. You're going to have a special function that you'll use for this. Now the word continuous may be given in the problem or the formula will be given, and the formula is P of t equal P sub 0 times e to the kt power. Let's look at a problem. In 2001 the population of India was about 1030 million and the exponential growth rate was 1.4% per year. Now what this means that when this problem started at time 0 there were 1030 million people. Now remember that's actually 1030 with 6 zeros to indicate million people. They had a growth rate of 1.4%. Now that's our R. So 1.4%. Now remember to convert to a decimal. We drop the percent, move the decimal 2 places to the left. That'll be 0.014. The problem says to find the exponential growth rate in terms of P. They just really want you to write the problem with the given information. So this will be P of t will equal, now remember our initial information was 103060 million people times e to the k, which was 0.014t. Now that's the first problem, and that's all they want is the function written out. Then they ask you to estimate the population in 2008. Well, from 2001 to 2008, time would be 7 years. So now we're going to say P of 7 is going to equal our initial population times e to the 0.14, got to put a 0 in there, 0.014 times t, which is 7. Now go to your calculator and we're going to enter this in. I'm going to get this on the right. Alright, we're going to put in 1, 0, 3, 0, 1, 2, 3, 4, 5, 6 zeros times, now to get e to a power I'm going to go second ln, and now you see e raised to the, and I want 0.014 times 7, close my parentheses, equal, and I have 1136051669 people, or 136 million, and that's the way your book or your problem was given. So that many people at the end of 7 years. Now one that probably you will use more for our purposes is a money problem. Suppose that P is invested at an interest rate K compounded continuously. There's your clue to use this formula, and grows at 7% per year. The balance P of t after time t in years is given by, and here's my same formula we had above. What is the growth function in terms of P? You need to write the problem with what you're given. I am told in this problem that K is 7%, which is 0.07. That's what I'm given. So my function, my original problem, will be P of t equals P sub 0, whatever that is, times e raised to the rate, which is 0.07, times t, whatever that is. Now the first thing they want you to do is just write the problem with what you know. Now they give you some more. They say, now look, we want to invest $5,000. So that'll be P of 0. That's what you're going to walk into the bank and invest. And t is going to be 7. We're going to leave this money 7 years. Now the continuous is what's going to always throw you into this formula. So P at the end of 7 years will be my $5,000 times e to the 0.07 times 7. Now I would have to have a calculator for this, and you know that. So let's clear this out and do this. 5,000 times second ln, that gets me to E, 0.07 times 7, close parentheses, and equal. Now remember, we're talking money here. This is $8,161 and 0.581, so that's 0.58 cents. That would be my money that I would have at the end of 7 years. Now you might do one other thing, and this is a good what if for life. When would your money double itself? In other words, if I put 5,000 in, I want to know when I would go back, what year, and my money would be $10,000, double. So I'm going to take my problem. Now remember, I want to go back and get $10,000. I started with $5,000. I had 0.07 rate, but I don't know the years. Now remember, this time I do not know the time. Now I think before I do anything, I want to get rid of this coefficient. I'm going to divide both sides by 5,000. That leaves me here e to the 0.07t. 5,000 into 10,000 leaves me with 2. Now this is a problem such as we had in the first section of 4.5. I can't get a common base. I have an e. I'm going to put a natural log on both sides of this problem. Then I'm going to move my exponent down into the coefficient position. I'm also going to remember that natural log of e is 1. So I'm going to have natural log of 2 divided by 0.07 is going to be t. Now I'm going to go to my calculator at this point, and I'm going to say natural log of 2, close my parentheses, divided by 0.07, and I get 9.9 years. Okay, compounding continuously. This is when you're going to use the formula with E.